All right, in this video, we're going to look at converting between standard and general form of quadratic expressions. So for a quadratic function or expression, we'll get into functions later, the general form is y equals ax squared plus bx plus c, as we saw in our previous video, where, again, a, b, and c are real numbers, and a is not equal to 0. If it was, we would have just bx plus c, which is a line, and not it's not going to produce a smile or a frown. So the standard form, also known as the vertex form, is y equals a times x minus h in parentheses squared plus k. Now, the reason we call this the vertex form is because h and k represents the x and y coordinates of your vertex. So in this form, it's really quick to see what the coordinates of the vertex are going to be. And then a is not equal to 0, and a, h, and k are all real numbers. And also, by the way, this value of a that's in front of the parentheses for our standard form is the same a that's in front of x squared for our general form. So we're going to look at how to convert from y equals ax squared plus bx plus c form, that general form, to our standard form of a times x minus h in parentheses squared plus k. So we're going to start by finding the vertex, and algebraically, to find the vertex, the x coordinate, the value of h, is negative b over 2 times a. So for whatever values we have for a, b, and c, if we take the opposite of b and divide it by 2a, that'll give us the x coordinate of our vertex. The y coordinate is what we get when we plug that value of x back into our expression. So we just evaluate the expression at whatever this x coordinate is. That's the algebraic and traditional way, and it's really great if you don't have any graphing technology available. However, most graphing technology makes quick work of finding the vertex when it's in general form. So I'll show you an example where we use each method, and you can compare and contrast. And then again, the same value of a that you have in front of x squared, you're just going to copy in front of your parentheses for standard or vertex form. All right, so example 2, we're going to convert each to standard form. Part A here, we have y equals x squared minus 4x plus 3. For this one, I'm just going to go ahead and use the old algebraic way just to show it to you. So we get negative b, or we get negative b, which is negative 4, all over 2 times a equals 1. And that gives us an x coordinate of 2. And then to find the y coordinate, just evaluate x squared minus 4x plus 3 at x equals 2. So that gives us 2 squared minus 4 times 2 plus 3, which comes out to equal negative 1. So our vertex is at 2, negative 1. Which means now, looking at the value of a, in front of x squared, there's assumed to be a 1 if there's nothing written there. So a is 1, h is 2, and k is negative 1. So we got a 1 in front of the parentheses, or you don't have to really write it if there's just a 1. And then we have x minus 2 in parentheses squared, and then plus negative 1, we can just write as minus 1. So again, the h is the x coordinate of your vertex. The k is the y coordinate of your vertex. So here's our general form written in standard or vertex form. Part B, this one we're going to use technology for. So we have 6 minus x squared. Well, let's just rearrange these so we go from x squared all the way down in order for highest power of x down to lowest. So rearranging the terms, we get negative x squared minus x plus 6. And if we use technology, we can find our vertex to be at negative 1/2 and 25/4. Again, you could still use negative b over 2a and then plug it in here. Don't worry about this g of x part here. We'll explain this later. You can still just use y. You don't have to worry about this. But again, we get negative 1/2 and 25/4. So our value of a in front of x squared is negative 1. So we get y equals negative 1 times x minus a negative 1/2 becomes x plus 1/2. We're going to square that, and then plus our value of k is this y coordinate of 25/4. So the standard form of 6 minus x squared is negative the expression x plus 1/2 all squared, and then plus 25/4. One last thing I want to point out, the way we looked at going from standard form or from general form to standard form is sometimes also known as completing the square. So if you come across the phrase completing the square, that essentially means what we're doing here to go from general form to our standard or vertex form. All right, so that about does it for this video. Thanks for watching. I'll see you next time.